All right, so now we're back for part 3. We're going to look at a word problem here, and it's called finding the height of an airplane. An aircraft is spotted by 2 observers who are 1,000 feet apart. Okay, so the observers are A and B. Here's 1,000 feet. This is my airplane. Yes, I know it's a terrible drawing. As the airplane passes over the line joining them, each observer takes a sighting of the angle of elevation to the plane as indicated in the figure. So for person A, the angle of elevation is 40 degrees. For person B, the angle of elevation is 35 degrees. How high is the airplane? Now when we talk about height, first of all, height is always going to be a perpendicular. Okay, so that's what we want to find. Now there's actually 2 ways you can solve this. You can do SOHCAHTOA. I will show you SOHCAHTOA in a moment, but that's actually not going to be the easy way to do this. So what we're actually going to do here, we could use SOHCAHTOA. SOHCAHTOA would be really nice if we knew this length or if we knew this length. The problem is we don't know either one of those at this point. However, if we look at the big triangle, we could figure out, let's see, we could figure out this side, or we could figure out this side by using the law of sines, because we know this angle here, all 3 of these add up to 180. So 40 and 35 is 75, subtract from 180, this is 105 degrees right here. So if we take, now we can do the law of sines. So let's say I call this x right here. So we could do the sine of 105 degrees divided by 1,000 is equal to the sine of 40 degrees divided by the opposite length x. Now notice I'm ignoring my altitude, my height at this point. I'm looking at the big triangle here. And we could solve that. So x, I'll work it out. X times the sine of 105 degrees is equal to 1,000 times the sine of 40 degrees. But then I'm going to turn around and divide by the sine of 105. And now it's a calculator problem. So we've got 1,000 times the sine of 40 degrees divided by the sine of 105. Enter. 665 point, I'll go to 46. I'll round it to 0.46. So x is equal to 665.46. Now that's not the answer, that's not the height. That is this length right here. But now that we know that, now we can use SOHCAHTOA, where if I use the 35-degree angle, the opposite length is h, the hypotenuse is x, and so let's see, SOHCAHTOA. So if I'm doing opposite and hypotenuse, that is the sine. So we could say sine 35 degrees equals h is the height, but that's my opposite, divided by 665.46. And to solve this, I like to make it into a proportion. I put that over 1. 1 times h is h. And then we're just going to multiply that. Now what I'll do is I'll take this whole thing before I rounded. So there's my answer times the sine of 35. And we get 381.7 for the height. The height is 381.7, and this is feet. Okay, that's important. If I'm talking meters or I'm talking feet, I need to make sure I'm being consistent. Okay, that is the easy way to solve this problem. So, what's another option? Well, let me draw this again here. So here's 40, here's 35, here's 1,000. Now what we want is this. These are both right angles here. So, if I wanted to just use SOHCAHTOA from the very beginning, if I could figure out either this length or this length, I would have enough to do sine, cosine, or tangent. The problem is I don't know what these are. I know that the total distance is 1,000, but I'm not sure how that's broken up. It's not 500, 500 because these are not equivalent angles. It's not an isosceles triangle. So I'm gonna call this x, this length. Now, if that's the length of this piece, whatever's left over is 1,000 minus that. So that's 1,000 minus x, because the total is 1,000. So what we can do here, if I look at this triangle, now here's 40 degrees, I'll use that. This is the opposite side and the adjacent. Opposite adjacent is tangent. So tan 40 degrees equals h over x. All right, well, there's two variables there, so I'm gonna leave that for the moment. In the other triangle, the other right triangle here, I could also do tangent using 35. Opposite is h, here's my adjacent. The tangent 35 degrees equals h over 1,000 minus x. All right, now what I'm gonna do here is I'm gonna solve both of these equations for h. So I'm going to, if I cross multiply here, I get h equals x times the tangent of 40 degrees. And then here I get h equals 1,000 minus x times the tangent of 35 degrees. Now what we've got here are two expressions that are both equal to h. So that means they're equal to each other. X times the tangent of 40 degrees equals 1,000 minus x times the tangent of 35 degrees. Now the nice thing is, this equation only has one variable. The problem is that that equation is being, or the variable is repeated. I need to distribute first. So x times tan 40 degrees, that doesn't change. This would be 1,000 times the tangent of 35 minus x times the tangent of 35 degrees. All right, I'm gonna move this x term over to the other side by adding it. So x times tan 35. Now I can't just combine these because these are different. So this is x times the tangent of 40 degrees plus x times the tangent of 35 degrees is equal to 1,000 times the tangent of 35 degrees. I'm going to factor an x out of both of these terms because they both have an x. So if I do that, okay, I'm kind of running out of space here. So if I take out the x, what that leaves me with is the tangent of 40 degrees plus the tangent of 35 degrees equals 1,000 times the tangent of 35 degrees. And then the last move here, I need to, this is x times this expression. To undo multiplication, we're going to divide. So I will divide both sides by the tangent of 40 plus the tangent of 35, and I'll divide that by, running out of space, the tangent of 40 plus the tangent of 35. Okay, now this is a calculator problem. So I'm going to type 1,000 times tangent 35 degrees divided by the tangent of 40 degrees plus the tangent of 35 degrees. All right, that's a lot that I have to type. All right, looks right. Enter. 454.88. Now, you'll say, wait a minute, that's not the answer. You're right, it's not, because that is the value of x. Okay, so x is 454.88. That is this value right here. Now we're trying to find the height. So we're still not there. We're close though, because if I look at this triangle, this is 454.88. Here's 40 degrees, here's h. Opposite and adjacent is the tangent. So I can say the tangent of 40 degrees equals h over 454.88. And then h equals, if I multiply that out, so 454.88 times the tangent of 40, what we get is 381. Now it says 0.69, so I'd round that up to 0.7. Same answer. Okay, now again, looking at the work, you could do this if you wanted to use SOHCAHTOA all the way through. But this is where the law of sines is really nice, because this is certainly much clearer and much simpler than going through this whole process here. And that is the end of that notes.